Welcome to the introduction of the alpha release of the Neuron Robotics Kinematics display and control application. What we're going to be going through today are some of the features that are currently implemented and demonstrating the functionality of our forward and inverse kinematics control systems. First, you can see our application here is a graphical display of all of the internal data of the robot control system. Along here, you have the information of where the individual joints and a link are, and along here you have all of your task space control systems. This is the current position of the robot, and these are the current target pose and a new target pose to be set to the robot. As I move my arm around, you'll notice the current actual pose field changes based on the 6-DoF frame transformation of the tip of the robot relative to the base. As you can see with the hardware, we have an arm here that is a serial manipulator. It is providing the input to our control system, and across on the other side of the laptop we have our beta of a delta robot arm that is taking the inputs and turning them through our inverse kinematics into an output tip position. You'll notice that these robots are moving one-to-one in task space. In addition to this, we have an alpha of a graphical representation of the robot itself. This is a 3D model of the entire robot and each of its individual links. The models for the individual links that actually reflect the hardware is a feature that is going to be added in the near future. But in the meantime, we simply have labels to identify each of the links and how they're moving. And as you can see, the latency is very low. We have about a 30 millisecond latency between a motion in the real world and a software update happening inside the controller, and then another 30 milliseconds before it is actually reflected in the output of the servo motors for the delta arm. Thank you for watching.